Hello. Let me go over homework 5, what you need to do for this homework. And this homework covering correlation and regression, which is one of the most important topic in statistical and being used in evidence-based practice many times. So there are first question and second question are very similar. So I go over the first question, and here we have a student in freshman and the number of hours and their grade. What was their grade? If someone studied 1 hour, it was made 60, and 2 hours 65, and so forth. And I ask you to find the first part. If you see the scatter plot, tell me what you're seeing here in terms of if you see any linear relationship or what direction it is positive or negative. And then I ask you to calculate the sample correlation. The sample Pearson correlation, and then test a statistic, and then make conclusion about that. So in order to calculate the correlation, you need to use this table. So yeah, I posted for you. So you have the sum, the x is 40. That means adding all these columns would be 40. Adding all the y column would be 789. Then you square each of the row, and then adding up is 190, and so forth. The same y squared. So you need that information to calculate it. So in order to calculate the correlation, again, using the formula for correlation, you're using basically this formula. So first you wanted to calculate your SAXX, SAYY, SAXY, which if you look at the formula, this is the formula. Here, the sum x squared means you square each value and then you're adding up that column, the total you put it here. The sum x is the column you first add all the value, then you square it. So, and then you calculate easily all these three terms, put it in the formula, you get the R. And the same here. If you look at this example, the sum was, for example, squaring each value and then adding up, you got 57.9, and then minus you square this value, 16.7 times 16.7 divided by n5, you got 1.42. The same way here, we calculate SAYY and SAXY and use the formula, we got 0.94. So, and the other part is test statistics. You calculate the t statistics by putting the correlation, then square root n minus 2, 1 minus r squared. Remember, if your r is negative, your correlation, then you put in parentheses squared to become positive before you subtracting from 1. And then anytime you calculate your test statistics, the way you find if it's you rejecting or not, if your test statistic is greater than table value, then you reject the null. The table value here we had our n was 10, so we would look at alpha 0.05. You go look at the t table for two-tail, you look at 0.05, and then the 9 value is 2.62. So that's the value you need to compare to. That's the value I find. So since this value is greater than this value, you reject the null, and you would say there is a linear relationship. So you do the same thing for this problem for part A, B, C, and D. And the same for second problem, you do the same thing. And the last problem is only different here, which is you calculate the sample correlation coefficient. And if you look at the tips I posted for you, so you can use that table. So basically, you rank from lowest to highest for anxiety. You rank for lowest and to highest for physical activity. Then you get the difference. You square. You get that. You are adding all those square. You get the value. So 314. Then you using this formula, the sum d squared basically is your 314. You can calculate the correlation from that. So I would suggest you just do a practice for yourself. See if you can come up with the same table I posted for you. Problem 3 is when we have situation, you wanted to look at the correlation, and also you want to control for third variable or more than one variable. So here our anxieties are y, physical activities are independent variable, and smoking is our controlling variable. So usually you see metrics like this when you do correlation. The diagonal is 1 always. That means any variable correlated to each other is 1. And then basically here we have 3 correlation: anxiety and physical activity, anxiety, smoking, and physical activity and smoking. So and you can use either upper diagonal or lower diagonal. It's the same value. So the question I asked, what is the highest correlation? You find it from that table and tell me what it is. And then partial or semi-partial correlation. Again, looking at your tips or your handout, you want to use the formula for those correlation. Remember, basically you're replacing. Here we said our anxieties are y. So your y is and 1 is your physical activity. X1, we put the notation as 1 because sort of make it shorter notation. So basically what it means here for partial, you put the correlation between anxiety and your physical activity, which is negative 0.6. You put that term here, minus, you put the correlation between anxiety and smoking, which is 0.8, in parentheses, times the correlation between your physical activity and smoking, which is negative 0.4. And then you have 2 terms here. For partial, you taking the effect of smoking from both your physical activity and your anxiety, your outcome and independent variable. In semi-partial, you just taking the effect of controlling variable from your independent variable, which is physical activity. That's the only difference. If you see, the term is 1 term. The numerator is the same, so you can calculate 1 numerator for both. So that's what is partial and semi-partial correlation I wanted you calculate. Now, question 4, we move into simple regression when you have 1 independent variable and 1 outcome. I ask you to look at the SAS output and find the predicted variable. So this is basically your ANOVA for a SAS output, and it shows you overall model if it's significant or not. And if your p-value, this column is p-value. If your p-value is less than 0.05, that means it's significant. This is your intercept, and this is your slope. So when you write your prediction equation, which is your outcome, your y hat equal to your intercept and plus your slope times your independent variable. So that is basically your prediction equation. So you can find it from here. And then I ask you, look at the residual plot. And in this plot, you want to see if there is a pattern or not. If something, you don't see the pattern, you would say you're not seeing a pattern. The pattern means when you have a sort of something not linear or it's quadratic or cubic, like going up and coming down, like, you know, so those are kind of pattern you wanted to look at it. And then I asked you to find the R squared and adjusted R squared. You have it in the output, you can figure out. And 95% confidence interval for your slope. Remember, this is your slope and this is your intercept. The standard error, I'm sorry, standard error. So you have these two values. Now, if you look at the regression, what you wanted to, in order to calculate the confidence interval, you have your slope plus minus the t value from table times the standard error. So you have your standard error, you have your slope. The only thing you need to find is t. So you have n here, 10. Again, you go to table, two sides, and you would look at the degree freedom 8 and intersection with your 0.05, which is 2.236. That value used, and then you can calculate easily your confidence interval. So, and the last part of this question is when you wanted to predict some value. Here, if you look at, for example, we don't have 3.5. Now the question, if someone studied 3.5, what would you expect would be his or her grade? So basically you put 3.5 in your prediction equation instead of independent and get that value. So that question 3. Question 4 basically is similar to that question, prediction and looking at the residual. And the C part is a little bit different, and I ask you to test if it's significant. Remember, this column is your p-value. So anytime your p-value is less than alpha, you reject null and you would say is significant. If your p-value is greater than alpha, you fail to reject. And then the last part is again prediction. You put 85 in your equation and solve the problem. And the question 6 is related to multiple regression. So when you have several variables in the model, again, I ask you to fit the model and find your prediction equation. Remember, here all these 2, 4, 6, 7 variables you have, and these are the basically a slope for each of those variables, and that's your intercept. Basically, you expand your simple regression to multiple regression. And these are the p-value. It tells you which variable is significant in the model. So that's you wanted to find, and finding the R squared and adjusted R squared again from the output. And now for prediction, because we have several variables, basically you replace these value in the equation and find out what is the value, predicted value. So that's you need to do. And then for question 7, you have 2 manuscripts which I asked you to look at it. One was factor related to health. So you would look at the table and tell me what sort of procedure was used for the table for the health promoting, what the statistical tests used, and what are the outcome in table 3 and 4. So basically you're looking at, again, this manuscript. So there are table 3. Easily you can guess what the statistical test used. So the end of manuscript is your tables you wanted to look at. This table 1, this table 2. So this is your table 3. And here basically tell you what, in heading basically tell you what test is being used. And these are basically your slope. These are the p-value. Remember, any p-value less than 0.05 considered as significant. So you can answer those questions. And also the same, you using the second manuscript for the question, the last question to answer. So that shouldn't be difficult to look at it. So I ask you to look at some of these correlation and respond it. I hope that these tips help you to understand better to how you do this homework. And if you have any question, you can always contact me.